Additionally, in order to facilitate the implementation of this kind of thermal network concept, we have developed a design support tool in order to facilitate the design and dimensioning of the innovative thermal substation that I have just explained. So this is a very user-friendly tool that has the possibility to import the heating demand, cooling demand, and local production profiles that are used as input data from simulation programs, or in the case of already existing district heating systems, from monitoring platforms. It is based in simple but reliable steady-state calculation algorithms, and it has been implemented in Excel in order to make it very user-friendly. This design support tool will provide the substation topology that is the most suitable one for each specific application. It will evaluate the potential for each specific case, for any specific case, of the implementation of the heat recovery from the cooling module functionality. And finally, it will allow us to dimension the nominal power of the required heat exchangers, and if necessary or if desired, to make a selection of a commercial heat exchanger from several commercial catalogs that have been integrated in the design support tool. This is a picture describing the interface of the design support tool. As I was explaining before, it is very simple. And finally, a summarized description of the benefits provided by this innovative smart dual thermal network concept. As said before, this thermal network concept will allow us to upgrade a standard district heating system to an advanced district heating and cooling system without the need of installing a dedicated district cooling plant, and without having to deploy an additional thermal network to distribute the generated cool water. Additionally, and thanks to the smart interaction with the thermal network, we will obtain higher production values of the renewable systems that are located at building level. And in the same way, thanks to the virtual district plant concept and the smart interaction with the thermal network, we will also obtain an increased operational season and production from the CHP units located at district level. And additionally, thanks to the model predictive control approaches that are implemented through the deployment of the integrated district energy management system, we will have the choice to optimize all the settings of all the systems that are located at district level, but also at building level. And finally, we will also obtain the advantages mentioned before by Francesca. Free hot water during winter season in heating operational mode, and free cool water production and free low temperature hot water production during summer season while the collectors are operating in cooling mode. And finally, the list of the boundary conditions that must be fulfilled in order to ensure a successful implementation of the thermal network concept. First of all, we will need to have a complementary level between the demand and the local production profiles of the buildings connected to the district that can provide us synergies in order to obtain all the advantages that I have mentioned before. We will also need to have a relevant presence of aggregated heating and cooling loads. We will need to have an adequate balance between the price of the fuels used in the CHP plants, mainly gas and biomass, and the electricity prices. Obviously, we will need to have favorable regulations regarding distributed electricity production technologies. And finally, it will be necessary to implement, if it is not already available, an integrated district energy management system in order to have the choice to implement these relatively complex control strategies. It is also true that when all these conditions are not fulfilled, that we still have the choice to have partial implementations of the thermal network. For example, if we don't have a relevant cooling load in the district, we still have the choice to implement the smart thermal network using or implementing the smart interaction between the buildings and the thermal network. Or if the complementarity between the demand and production profiles of the buildings connected to the district is not high enough, we will still have the choice to implement a dual thermal network where we will provide the energy necessary for cooling and for heating using a single distribution network. And finally, the evaluation of the expected performance for the smart thermal network. As obviously, a full-scale implementation of this smart thermal network would be too costly and too complicated. We have created some virtual demo sites in which, through a sequential offline co-simulation process, we have evaluated the expected performance in order to validate the actual potential of our innovative thermal network concept. And additionally, as explained by Francesca before, we are evaluating the performance of the absorption collectors in an educational demo district located in Ankara that hopefully will produce very satisfactory results. And if there are no questions, this was all. Thank you.